Okay, let's get started. We have a couple of announcements first. I'll pass the mic on.
Hi, I'm Cindy. I'm a junior in computer science. And I just want to let you all know that there's a new club on campus called Women in Computing, and our first event is today right after class from 4:30 to 5:30 in the Catmull Gallery. There will be food there, and you can meet some new friends and learn about some upcoming events. So I would love to see you all there. This is not only for girls, guys can come too. So hopefully I'll see you guys there. Thank you.
In case you didn't catch that, the Catmull Gallery is the big lobby on the main floor of WEB, Warnock Building, right next to MEB, where your labs are.
All right, you guys, so I'm Vicki and this is Tracy. So we're the CS advisors and the EAE advisors as well. So how many of you attended orientation this summer? Okay, how many of you remember signing up for the peer mentoring program? Okay, 2 of you. Okay, so everybody should have signed up. Okay, so we're going to have our first event on Friday. It's going to be a social with your peer mentors. We sent an email out, so if you don't know if you signed up for it, check your email, because we sent an email to you guys. So check your email and check the email that you would have signed up under. And then it's going to be on Friday at 1 p.m. in Web L101. And then I'll let Tracy take over.
Okay. So when you check your email, there's going to be a link in there that you can go in and RSVP. So click on that and then RSVP yes, because you definitely want to come. It's going to be really low key. It's just going to be a chance to meet other people in the major and also your mentors. So they'll be there and they'll just be doing a panel and letting you ask them questions about 1410 or what 2420 is like or anything that you have questions about. So sign up for that, and there's also going to be pizza. So it's going to be free food, it's going to be lunch, so please come. Sign up through your email.
Okay, and again, that only applies for those students who got the email that signed up for it. So if you don't know if you signed up for it or not, check your email. That's how you know you signed up for it or not. Okay, all right, thanks guys. Thanks, Joe, appreciate it.
Any of you have any questions about the peer mentoring program before they get out of here? I highly recommend it. Okay, so we're week 3 now. After today, the semester is over 15% over, close to 20% over. So you may think we're just getting started, but we're not. We're in the thick of things. And since we're in the thick of things, at this point, everyone should be signed up with Piazza, and about 50 of you aren't. I find that really perplexing because there's no cost. It's easy to sign up. You can ask questions, see the answers to questions. I've posted several announcements for the whole class there that 50 of you haven't seen. For all I know, I gave an extension on a problem set or something. You won't know unless you sign up for Piazza. Yeah, I didn't give an extension that you don't know about, but it could happen. Some of you haven't subscribed to the Zybook yet, which is perplexing because it's part of your grade. It's actually 12% of your grade. And it will really make the class go a lot easier if you do the Zybook, keep up with it. So please do that. First assignment, I gave a general extension up to Tuesday. So PS1 was finally due last night at midnight. And about 30 of you, or 20 of you, didn't submit that. I find that really perplexing. I think that assignment by itself is 4% of your grade. But more importantly, it's not just that you lose 4% of your grade. It puts you behind in the class, because the problem set is not something where I just test to see if you learned what I yacked about in class. It's where you're going to do most of your learning. Okay? Lectures are important, the Zybook's important, the labs are important, but unless you do the assignments, you're not going to learn the material very well. And by skipping the first assignment, PS1, you're suddenly behind on PS2. And this cascades really fast to where you're just completely lost. So be sure that you take all this stuff seriously and keep up with there's something coming to you every day. Okay? Those of you that find yourself kind of getting far behind, remember, you can sign up for one-on-one appointments with TAs, outside of the computer lab where you can try to get back on track. Currently, Stefan is the only one that I have that has a schedule online. If his schedule comes close to filling up, which actually it is, we'll just add more people to that. We'll add more TAs that you can make appointments with. So go onto go into the calendar in Canvas, and you can find a way to sign up for one of these appointments. And one other piece of advice: don't wait till the last minute to do anything. Things go wrong at the last minute, and you may find out you don't know something. It's a little late to find out if it's 11:58. Okay, so PS2 is out. It's due Thursday. So that's tomorrow. Yeah. So yeah, things start to come pretty fast. Any questions or problems before we proceed? Yes?
So we run the unit tests and they all pass. We should theoretically be fine with PS2, right?
Okay, so he asked if, so PS2 comes with some methods you're supposed to implement, 10 methods you're supposed to implement. And then a separate class, which is something called unit tests. They're just tests that run against your code. So he asked if he passes all the unit tests, is that good for the assignment? Well, there's a rubric, and you can see the rubric. And the rubric involves more than does your method work or not. So if you can write methods that work perfectly, but if you don't indent anything and use really bad variable names, I could see you losing some points. So be sure you look at the rubric to make sure you've covered everything we're looking for. Any other questions? Okay. Beginning of the semester, we talked about expressions for a day or two. And expressions, as you learned pretty quickly, are they're either literals or they're variables, or if they're not those, they're composed of simpler expressions. So expressions are composed to make ever more complicated expressions. And when you look at an expression, or the role of an expression in a program is that it has a type and a value. So expressions are the things that do the computing, that calculate new values. We quickly changed to talking about statements. And statements are composed of simpler statements and also expressions. Statements control the order in which things happen. So expressions have values. Statements control the order in which the expressions are evaluated. And we'll keep seeing new kinds of statements as we go along. But so far, these are the statements that we've seen. Variable declarations, which create a new variable that's accessible in its scope and optionally initializes it. Assignments, which change the value of a variable. Method calls, as long as they have some side effect. So a statement in a method might, the show message dialog call here might, very well appear as a statement. But it would be kind of silly to do math.square root of 17 as a statement because why? Why would it be silly to have that all by itself as a statement? Yeah?
It has no effect on anything else in the program?
Right, he said it has no effect on anything else in the program. Now, if you took that and stored the result into a variable, that's a statement. Or if you printed it out, that's a statement. But an expression, most expressions by themselves, they don't change anything. And so you need to do something with the value if you want it to have any effect. And finally, we looked at return statements when we talked about methods. And return statement, what it does is it ends the method, first of all. So when you execute to a return statement, the method is over. And furthermore, if the method is not void, the return statement identifies the value that's returned by the method. So that the expression that follows the return is evaluated and that value is returned as a result of the method. Yeah?
Well, you don't need to type return if it's void, you can just leave that out.
If you leave out return and it's void, the method will automatically return when it hits the end of the method, yes. Sometimes you want to put a return somewhere else. You want to end the method early. But by default, if it's void, it'll return when it hits the end of the statement, end of the method. Okay? So those are the 4 kinds of statements that we've looked at to date. Today we're going to add 2 more. Yeah? You can ask, what's the difference between system.out.println and return? Okay, well, who could tell me what system.out.println does? Yes? It prints something to the console. Okay, what does return do? Ends a method. They have nothing in common. You know? So there's the difference. Completely different. Any other questions? Okay. So I like to say that programs would be kind of limited if they couldn't make choices. It would be kind of hard to write interesting programs if they couldn't make choices based on data they could see. And so this is a conditional statement, or an if statement. So when I said for PS2 I don't want to see any conditionals, what I meant was I don't want to see any if statements. And the structure of an if statement is, as we see right there, is the keyword if, followed by a Boolean expression in parentheses. So a Boolean expression is just an expression whose value is true or false. And then some statements enclosed in braces, maybe an else if, and then maybe an else. So that's the formal syntax of an else if statement. We'll look at examples. You'll learn it through the examples, not from this picture on the screen here. But there can be exactly one of those. So every if statement has to start with if, some condition, and then a block of statements. It has to be exactly one. You can have optionally 0 or more of these else ifs. You could say if, else if, else if, else if, else if. And then the else is optional, but you can't have more than one. So lots of ways to construct else if statements. And again, okay, that's a nice picture, but it's kind of stylized. We'll look at examples and this will, I think, make a lot more sense. But it's a way for a program, for a method to make a choice. And the way to think about it is if the first expression is true, then the first bunch of statements is evaluated. If the second bunch of statements, if the first expression is false and the second one is true, then the second block is executed and so on. But only one of the blocks is ever executed. So that's what an if statement looks like. And as I said, we'll look at examples. Now, I also like to say that programs would not run very long if they could not do repetition. I mean, programs are really fast. They might execute, you know, say a billion statement, well, not a billion lines per second, but, you know, hundreds of millions of lines per second, let's say. And so you'd have to write a really long program. It'd take you a very long time to get a program that ran for a second. You had to write 1 million or 10 million or 100 million lines of code. So good thing that there are things called loops. And this is the general form of a loop, of a while loop anyway. It has the keyword while, and then a Boolean expression, and then a bunch of statements. So syntactically, it's simpler than an if statement. And it just says, while that expression is true, or if the expression is true, execute the statements. And then do it again. If the expression is still true, execute the statements again. And you keep doing that until the expression is finally false. And then you move on to the next statement. So a very high level view of loops. Let's look at it in action though. Let's write a method here. So I want to emphasize something because I've been hearing, I'm familiar with the problems people have on PS2. On PS2, you're not writing programs. You're implementing methods. So these methods don't stand alone. To use the method, you'd have to do something like up here. You could write a main method that calls the methods. So like this line right here, this main method would call max with 8 and 12 as parameters and print out the result that it gets back. Okay? But by themselves, they're not complete programs. So where do the values of x and y come from? I've had that question more than once. Let's say you're writing this max method. How do x and y get values? I get students that want to, interact with the user. The first thing the method does is say enter the value of x, enter the value of y. And I tell them that's not right. But what is right? Where do x and y come from? Yeah?
When you call the method, you give the parameters.
Yeah, they come from whoever called the method. We don't have any control over it. When the method is called, once it starts running, x and y will have values. They will have come from whoever called the method, from wherever the method was called. But we don't have control over that as the implementer of the method. We just have to deal with what we're given. And you can see right here, when max is called from that point, 8 and 12 will be passed as parameters. So you're just implementing the method. You're not writing complete programs. And it'll be that way for a few weeks. We're not writing complete programs. You're writing parts. Okay. So I want to return the larger of x and y. Now, there's a math.max method that we could use. We could just say return math.max of x and y. And that would work just fine. You might want to use math.max in the current assignment so that you can avoid using an if. But I want to show how we use an if. So let's pretend that math.max doesn't exist. Now, I claim that we need to make a choice. We need to decide what? What choices do we have to make here? Yeah? Right, we have to figure out which is larger, x or y. So since we have to make a choice, we use an if. So it looks like this. If x is greater than y, we do something. Else, we do something else. So that's sort of the simplest form of a conditional. If something is true, do one thing, else do the other thing. So the conditional is controlling which statement or which statements are evaluated. Okay? So someone tell me, what is the thing we should do if x is greater than y? Yeah. Right. If we know x is greater than y, we don't have to do anything other than just say return x. Whatever x is, it's the larger, so we return it. And what is the thing we should do if x is not larger than y?
Return y.
Return y. And because we got returns in there, we never go past the if statement. There's no way to hit the bottom of the method because we return from inside the if statement. Yeah?
What about if x and y are equal?
Okay. What about if x and y are equal? First of all, yeah, what's going to happen? Yeah.
You're going to return the maximum value because either one of
Okay, so he's saying if x and y are equal, it doesn't matter which one you return. They're the same, right? So what will happen here? What will the flow control look like? If x and y are the same, is that going to be true or false right there? That's false, so it will return y. But if x and y are both 10 or 15 or whatever, the user won't be able to tell any difference. Now, we could write it this way. Is the program still correct if we write it that way? Yeah. Internally, something different is going to happen when x equals y. It's going to return x. It'll execute a different return statement, but the outside user can't tell the difference. So they're both correct. Okay, so that's your first example of a conditional statement, an if statement. And in programming, we end up writing a lot of them. Yeah?
Should you have an else if statement for when x equals y?
I could say if x is greater than y, return x. Else if x is double equal y, else. I could have 3 cases, but it's really not necessary. I don't need to break out the case where they're equal. Now, if you want to run the method, let me show you 3 ways to do it. One is to write a main method that calls max. Okay, so we can run that. And then it will print out in the console 12 and 0. So it found the max of 8 and 12 to be 12, and it found the max of 427 to be 0, which is wrong. Why did we get it wrong? Something wrong with our max method?
Just return 0.
Well, but it's not supposed to return 0. It's supposed to return 7. Yeah?
Well, it takes 2 parameters.
Right, our max only takes 2 parameters. There's another method down here that takes 3. We haven't implemented it. All right. So just because they have the same name doesn't mean it's the same method, as long as the parameters are different. So that's one way to do it. Another way is to look at the unit tests here. And it has a bunch of tests, and we won't worry about writing them just now. I wrote them for you. But if we run those methods, and what pops up over here, which is going to be hard for you to see, is there are 10 test cases, and we passed the one called test max 2 and failed all the rest. And these were the tests for max 2. It made sure that the max of 4 and 5 was 5, that the max of negative 20 and 8 was negative 8, and the max of 0 and 0 was 0. And now that we got it here, it's easy. If we change our program and want to rerun the test, there's a place right here to rerun it. And we had the question earlier, you'll have these unit tests for PS2. So you can just keep it off to the side and run the tests every time you make some progress and watch everything turn to green eventually. Hopefully. What's the third way to do it? Third way to test one of these methods. Yeah?
Use JShell.
Use JShell. So to use JShell, if you come to the file menu, you'll see launch JShell. But that will launch JShell, but it won't know anything about your project. You won't be able to run the code in your project. So if you want to have a JShell that knows about your project, right-click on the project and click Launch JShell there. And it'll show up down here at the bottom. And not only does but you can see that it knows about your project, because I wrote it so that it will automatically import all the packages in your project. So you see it imports, down here at the bottom, you see it's importing CS1410. So that means we can run the method. So it's conditionals.max 32 and 8. So we get 32 back. If you want to try something else, like 3, you do that. So that's easy to use, you just leave it there. Let me just tell you one thing. If we're going to go back and modify our class, and JShell won't know about any changes we make to the class unless we do this. I won't do it now, but slash reload will reload the class, your modified project, so you can continue testing. But it will only work. The original version of the plugin, what it did when as soon as your project was rebuilt and changed, it killed JShell to force you to reload it. I didn't realize there was this reload thing built into JShell. So it won't work this way for you unless you update the Canvas Project Manager, which I pushed out just last night. So to do that, you just come to Help, you click on Check for Updates, and it will find the update and you just install it. Okay? Otherwise, it won't quite work like I'm showing you here. Yes?
How do you get to print out all the import statements?
Slash imports. Yeah, so we go back up here. That shows you what was imported, and everything, and all this stuff is automatically imported by JShell, except for this last bit, which I'm taking care of for you. Okay, so 3 ways to play with it. If you didn't have the test cases, I think JShell would be a lot easier than trying to write main method code all the time. Okay, so back to conditionals. So we've got that. Now, what about this method here? We've got to find the largest of 3 things. What's going to be different here? Yeah?
You're going to need an else if.
Okay, so we're going to need an else if, and the reason is there's 3 possibilities, right? Either X is the largest, Y is the largest, or Z is the largest. So that's 3 cases to look at. Yes?
Could you use the other max method to compare 2 of them and then compare that max to whatever the third one is?
Yes, we could. That's a great idea. Thanks for suggesting it. Let's do it this way, and then I'm going to change it because I want to show a 3-way conditional. How could we use the existing max method? He just said. Someone else tell me what to type. Yeah?
Use the max on X and Y, and then use the max on that one and Z.
Okay, so if we did return max of X and Y, so we're just calling our other method, that would return the larger of X and Y. But we can do this. Right? That says return the larger of Z and the larger of X and Y. So we're going to get the largest one out that way. And of course, we can just use math.max. Now, it may look to you like I'm cheating, because every time I've ever called a static method, I've always had to say conditionals.max, like I am right here, or math.max, class name dot method name. but there is no class name here. What's up with that? Why don't I have to say conditionals.max? How does Java know I mean conditionals.max, not math.max? Yeah? It's because I'm already inside the conditionals class. So by default, it assumes you mean the class you're in. Okay? So we can do that. And if I save it, come down here and reload, and come back here and take the larger of these. Great, it works. But that's nice, but I want to have another goal, which is to show how conditionals work. So we need a three-way conditional if we're going to do it from first principles, right? You got a question?
Methods called max, even though you're already working in one called max. How does Java know which one to?
Okay, so he's asking right here, the code I just commented out, when Java sees max here or max here, how does it know I don't mean this max? How does it know I meant this one? How can it tell? Yeah?
It's two conditions.
Two parameters. Yeah, it looks at the number of parameters. So right there, we gave 2 parameters to max. And so it says, oh, that's the 2-parameter version, not the 3-parameter version.
So if you just use 3 parameters, it would automatically just take the one parameter.
Right, if you use 3 parameters, you'll be referring back to itself. That's called recursion, which is a thing, but we're not talking about that today. Yeah?
Can a method call itself?
Yes, a method can call itself. That's usually called recursion, a recursive method. Since you asked the question, well, let's do it. Let's return the larger. After all, we got this max method, this 3-parameter max method right there. Let's call it. So we could do that. And let's come down here. Reload it. And when you reload, it also reruns all the stuff you've typed in before. And you can see when it ran, something went bad wrong. I'm scrolling up and nothing is changing. So basically what that's telling you is that max called max, which called max, which called max, which called max, until Java ran out of memory. So yes, a method can call itself, but you can't just directly call it. You have to be a little more clever. Yeah.
Is there a way to adapting just the way it is something?
Yeah. So
repeat.
When you have recursion, there's usually a conditional involved.
Repeat.
Oh, that's right. He said, is there a way to control it? Because it looks like here you just get an infinite loop. It's just, I think the simplest answer is, stay tuned and we'll talk about recursion. Okay, so you got one way to do it and one way not to do it. Now, I often encourage students, when they're about to write a method, implement a method, look for inspiration. And what I mean by that is, look for some example I did in class, or some example that you did earlier in your assignment or a different assignment that is most similar to what you need to do now. So where would be a good place to crib from here? Where do we look for inspiration for how to code this method? What's the closest thing we've done to it? Yeah?
Previous max with 2 parameters.
Right. So I might start with this one so I don't have to type so much. So I put it down here and I say, you know, that's nice, but I got to do 3 choices, not just 2. So I'll just throw in an else if, and I'm not sure what the condition ought to be, but something like that. Okay? So it's not going to be exactly what you need, but it's somewhere to start. So we've got 3 cases here. So in what case should we return x? What should this condition here be to ensure that x is the largest before we return it? Yeah?
X is greater than y and x is greater than z.
Okay. So we'll go back to greater than. So if x is greater than y and x is greater than z, do you all agree we should return x in that case? Was this the largest? Okay. Now, just for symmetry, I'm going to say return y right here because y ought to come next, and then at the end we'll return z. So under what circumstance should we return y?
Y is greater than x and y greater than z.
We could say y greater than, and y is greater than z, because clearly y is the largest, we return it. I think we can do it with with fewer keystrokes, though. Got an idea?
Wouldn't you only need the y is greater than z because we already checked y
Right.
against x?
So if we get to the else if part, I'm repeating what he said now. If we get to the else if part, we know that x isn't the largest, right? So there's really no need to compare y to x. We already ruled x out. All we care about, we've narrowed it down to x or z being the largest. So if y is the largest, we'll return y, otherwise we'll return z. All done. So let's try to reload this. I don't know what happens when you blow the stack in JShell. Okay. It started up nicely, so unfortunately it didn't print out the results for us, it just reevaluated them. And we get 45 out from that. Okay? So that's an example. That's sort of a three-way if statement. I gotta say, don't do this. Okay, so any questions about the three-way conditional? Now, your next assignment, PS3, will involve probably 10 methods again, and some of them will involve writing conditionals. So, always better to ask questions now than later. So, if at any point you don't understand something, please ask. Yeah?
After we made methods, you can call them from different packages within Eclipse, right? Or is it
Okay, so she asked, after you've written this method, you can call them from different packages within Eclipse. Yeah, once you create a method, you can call it from other classes. I would say classes rather than packages. Yeah. Now, what we haven't talked about is, typically, if you write a method, the only place you're going to call it from is from a different method in the same project. Because all the code in a project knows about each other. It's different if you have a project here and you want to call a class in a project over there. That involves some Eclipse hacking to make that all work. Any other questions? Yeah?
Is it possible to write a method with a variable number of arguments?
Okay, so he asked, is it possible to write a method with a variable number of arguments, like max? And yes, it is possible, and we will, turns out you have to understand about arrays to understand how that works, and we'll look at that eventually. Yeah? I didn't catch most of that.
Okay, so you know how for to use the scanner, you have to use Java that you tell the scanner?
Yes.
So my question is that, okay, so in that instance, is there basically already predefined classes and methods that you just have to call?
Okay. So he was observing that if we only use a scanner, it's actually, the full name is java.util.scanner. We have to import java.util. Yeah, and he asked, is there a standard supply of these things? Yeah, there's the Java library, and you just have access to it. You just have to know what the packages are called, and what the classes are called, and what the methods are called. And so far we've used classes like math, and integer, and double, and scanner, and string, and we'll gradually use more and more. But yeah, knowing what's in the Java library is a big help. Okay, let's write another method. This one wants the square root of the absolute value of x. And there's an absolute value method in the math package, in the math class. But the heck with it. Let's do without it. What do we need to do to calculate the square root of the absolute value? Yeah?
You want to make sure first that you are doing the square root of a negative.
Right, so what he's saying is we've got to avoid taking the square root of a negative number. So what I'm going to propose is that we just do a simple if, not even an else. So I'm going to say if x is less than 0, I'm going to do something, and then in the end I'm just going to return a square root. Okay, so what should I do here? Yeah. Yeah. So I'm saying if x is negative, then change x to be, negate x basically. If x contains -2, then we're going to set x to be 2 instead. That's what this if does. It just fixes up x. And then, no matter what, we're going to return the square root of x. Yeah? Yeah, right. There's an absolute value method, but what can I say? I'm trying to come up with simple examples, and the simplest examples are already taken, so I just don't, we won't use those. We won't use math.abs. Okay? So let's think about this. There's no else. So what happens? What does this if do if it turns out x is not negative? It just skips this, it skips these statements here, and goes directly to the return. There's no else. There's nothing I need to do for an else. So I just leave it out. If, on the other hand, x is negative, we make x positive in the correct way, and then we return its square root. So what I have here is, this is one kind of if, that's an if with only a single, just an if, no else's or else ifs. This is an example of an if with an else, which is also common. And this is an example of an if with an else if, followed by an else, which is also common. And sometimes you have multiple else ifs. If you've got 4 or 5 or 6 cases, then you end up with a bunch of else ifs. Yeah?
On the square root of absolute value method, I'm just kind of confused with the return and like the square root does on that last one you just did.
Okay. Right here?
Yeah.
You're wondering what this does?
Yeah, like what are we returning?
Okay. This is the square root method from the math package, math class. So we're just computing the square root of x. So let's say x is 100. Math.square root of x will be 10. And we return the 10. So what the return does is it evaluates this to obtain a value. This is an expression. Math.square root of x is an expression. It's evaluated, and depending on what x is, we get a number which we return. So we return that number. Any other questions? Okay. Now, if this were a history class, and we just finished talking about the Civil War, and some of the students weren't here or didn't pay attention or didn't understand, they could muddle on through the rest of the class. They just missed the questions on the Civil War on the final. This isn't a history class, it's a computer science class. If you don't get this bit, everything else we do depends on it. So you can't pick and choose what you're going to pay attention to, what you're going to concentrate on, what you're going to figure out, and which you're going to ignore, because everything builds on everything else. So keep that in mind. All right. So let's take a few minutes break, and then we're going to look at loops. All right, let's get started again. Here, I have a method for you to look at. It's called display for ints. And so what it does is you give it an integer. Let's say you give it 3. What it'll do is print out 3, 4, 5, and 6. So it prints out the next 4 integers, starting with the one you give. So hopefully it's, it shouldn't be that hard to understand how it works. There are 4 print statements, and each one prints out a slightly larger integer. Now, I would like to generalize that so that we still get the starting point as a parameter, as you can see right here. But rather than print out 4, we're given a number n that says how many to print out. So if n is 4, this will work just like the previous method. But if it's 100, it'll print out 100. The numbers from 3 to 102. So the number of times we print something out is varying depending on how the method is called. So a problem like this, where you've got to decide, let's do this one here. A problem like this, where you know in advance how many times you're supposed to do something, you can solve just by doing that thing that many times. But we don't know when we write the program how big n is. And so for this, we need to use a loop. Okay? And I'm going to show you how to write a loop that deals with intervals of integers. I'm going to show you how to write a loop that deals with strings, and one that deals with scanners. And these are going to be prototypical loops that you can reuse in other applications. So you'll see what I mean. So I need to display the ints. So I've got the count starting at start. I've got to count my way up to n. Okay? So I'm going to declare a counting variable, I'm going to call it. So I'm going to let that be my starting point. Var num equals start. Yeah?
What's the deal with var?
I don't know why I did that. It's added to Java in JDK 10, but I hadn't used it until right now. Forget I did that. We want an int called a number called start. Okay. And we're going to put a condition there that controls how many times the while loop iterates. We'll worry about that condition in a second. But each time through the loop, we're going to print out num. So the idea is we're going to write, every time through the loop, we're going to print out the number, and then we're going to make the number one bigger. Okay? Yeah?
Num equals 0, num is less than n plus plus. So I get started at num equals num.
You're trying to write a for loop for me.
Oh.
Okay. So how will we know? We need to give a conditional here that's true when we want the loop to go another time, and false when we don't want the loop to go another time. How big can num get? Notice every time through the loop, num gets one bigger. At what point is num too big? When do we stop? Let me get back there.
So if you have a statement that when start is less than n.
Okay, is it while start is less than, not start, while num is less than n? Is that what we need? Let's suppose start is 10 and n is 2. So we want to print out 10 and 11. But num starts out at 10. It's never going to be less than n. Yeah?
If you create a variable, keep track of how many times you add.
I could, but I want to make do with the variables I have here. Yeah?
Do num is less than num plus n?
Num will always be less than num plus n if n is positive. Yeah? I could, or he said, I'm going to rearrange it for you. So let's look at that. While num is less than n plus start. Okay? Maybe that's a little hard to, yeah, let's leave it like that. So the idea is, so when you're iterating over an interval of integers, you have some variable that's doing the counting. So we need to count starting at starting at start. And we need num to get bigger, 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 bigger. If we start at start and we go n times, suppose start is 10 and n is 10. What's the last number we want to print? Okay, suppose start is 10 and n is 2. What's the last number we want to print? Yeah?
11.
11. We print 10 and 11. We stop when num gets to 12, which happens to equal start plus n. If our first number is 1 and n, so if start is 1 and n is 10, we print out the numbers what? 1, 2, 3, 4. Where do we stop? What's the last number we print? 10 in that case. 10 is still less than start plus n, which is 11. So it turns out, you have to think about it. You don't always get it perfect the first time, but this just says you start counting with num, and when it gets too big, you stop. But each time it's not too big, you print it out, and you increment the number by 1. So I call this an enumeration loop. It's a loop that identifies, there's an interval of integers that need to be processed, and it does something to each number in the interval. So let's run it and see if it works. So I need to say conditionals.
You're on the enumeration loops now?
I call this an enumeration loop. That's just my name for it.
That's the class that you're in now.
It's just a style of writing a while loop. So I'm going to do conditionals.display into 5 to 10.
It's the name of the file?
Yeah. Your file name is enumeration loops, not,
Oh, you're right.
not conditionals.
The class is different now. Thank you. There we go. So we got the numbers printed out. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So let's look at the last time through. It printed, num was 14, right? It printed it out. It added 1 to num, making 15, and then it came back up and did this comparison again. So num was 15. What was on this side? Here's my call. Start was 5, n was 10, and so that sum is 15. So as soon as num hits n plus start, the loop ends. It doesn't print beyond what it's supposed to. Okay? So let's work through it from the beginning. In fact, I think next week you're finally going to learn about the debugger in lab. But I just put a breakpoint right there. Unfortunately, I don't think breakpoints work from JShow. So I'm going to run it from the main up here, which calls display for ints of 10 and 8. Anyway, I'm going to run it. Run the main. Oops, ran the wrong thing. So it ran JUnit. I need to come over here. I tell it I want to run enumeration loops. Debug. Okay, so it's trying to call display ints, and let's see what's going on. Start is 10, n is 8. So first thing it's going to do, I'll execute that statement, and now num is 10. All right, so it took start, it stored it in num. Okay, then it says while num, which is 10, is less than 8 plus 10, which it is. So it's going to execute that, the body. So the 10 is printed out, num is incremented, and we're back at the test. Well, now num is 11. These guys are still 8 and 10. So that's true. So the body goes again. 11's printed out, num is incremented, we're back at the top. Still true, print, increment. Still true, print, increment. Still true, print, increment. I'm getting a bit worried. What was 18? All right, I'm going to stop at 18. So it printed out that. So it tests it, it's still true. Still true. Now, num is 18 now. We've counted up all the way to 18. N is 8, start is 10. So now this is false, right? Num is no longer less than n plus start. Num is no longer less than our finish goal. So what's going to happen when I say execute the next statement? The loop will not execute, right? The loop body only executes. Instead, what will happen is the method will end. And I can just continue on. So that's a while loop. It takes a while to get used to it. Okay? And here's the thing. When you look at that and you go, what the heck? What's the right way to think about it? How do you have to think about a while loop? You can't just look at it and say, until you get experience and understand how it works. What's involved in understanding that while loop? How did I explain it to you? Yeah? Say again louder. Well, I wouldn't, he said an if statement that's repeated. I'm looking for something sort of lower level than that. What do you have to do to understand what a while loop does? Yeah?
Just go through the iteration yourself.
You got to go through the iteration yourself. You got to think, do the steps yourself. You just don't look at it and say, man, that's a lot of symbols, what's going on? Remember, statements cause computations to evolve over time. You have to be able to do what I did with the breakpoint. You have to be able to say, okay, it's going to set num to start. Okay, that's the first thing it'll do. Then it will do this test, and that'll be true the first time. Then it will do this, then it will do that. Now num is one bigger, so it'll do the test again. Still true. It'll do this, it'll do that. Then it does a test again, and just, you got to sort of walk through it in your head. Eventually you get to where you look at it and say, yeah, I understand what that's doing. Now, let me show you easy ways to mess up. Okay? What did I just do to make it not work? Why won't it work anymore? Yeah?
It'll print an extra number.
It'll print an extra number. Yeah? I want to print 10 integers beginning with start. So maybe that's all right. I print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm printing, next means consecutive integers. I'm printing consecutive integers, n consecutive integers beginning with start. Maybe that's better. Okay? So you have to run through it in your head. Now, I've been doing this for many years. I make mistakes like that, being off by 1. And I just know, I notice all the loops running more than one time, and I know my condition is a little bit off, so I fix it. So, that's the small stuff. Yeah, you got to get it right, but if you can get, if you can get this far, and have your loop not quite right, it's pretty easy to get it to work just the way you want it. So this is just a standard way of writing a while loop that runs through a sequence of integers. And the way it looks is we have some counting variable, which we initialize to something. Our condition, keeps we look at the counting variable, we don't want it to get too big. And then we do something with the counting variable inside the loop. And very important, we increase the counting variable. What would happen if you didn't do this? Yeah? That's called an infinite loop. The loop would never stop because num never changes, n never changes, start never changes. So that condition is true forever. So it would just run forever. printing out integers along the way. So if I do that, if I run it, there, you can see it. It's just printing out 10s over and over again, and it won't run out of memory. Now, I'd hate to have to throw my laptop away because it continues printing. So this red box down here in the console, if you click that, it'll kill the program. You don't have to kill Eclipse or anything. And I still make that mistake too, so I imagine you will as well. So that's a standard way of iterating over ints. All right. Now, this is a little bit different. I'm given a string, and I want to print each character out on a line. How do I do that? Where should I start for inspiration? Yeah. Well, I'm looking somewhere else for inspiration. Right? We got to pay attention to the length of this, but yeah. Yeah, this is only a loop we've written, so it's about our only source of inspiration. So I'm going to copy this down. Okay, so the standard way of iterating over a string is you declare a variable and call it something like index. And we're going to use index to be the location of a character in the string. So the first character in a string is at location 0, right? Okay? So we're going to write the loop, and we'll worry about the condition in a second. But each time through the loop, we're going to print out s.charat, the given index. So the first time through the loop, we're going to print out the character at index 0. Next time through the loop, the character at index 1. Next time, character at index 2. So what do we have to do with index each time through the loop? We need to increase it by 1. And how long, so index will eventually get too big. What is the index of the last thing in a string? If, say the string has 25 characters in it. What's the last index? It's 24, right? The indexes go from 0 to 24, not 1 to 25. So we start at 0. So at what point, how big can index be? What does index have to be less than so that we get all the way to the end but no further? Yeah? Right, we just take the length of the string minus 1. All right? And there's our loop. So that's the standard way to loop through a string. You have an index. You let the index increases until it gets beyond the length, until it gets up to the length of the string. And inside the loop, each time through, you increment the index by 1. And inside the loop also, you do something with the current index. In my case, I'm printing it out. Yeah?
So like, what's the index in this specific situation? Is it just will we assign it to 0?
Well, it starts at 0. So the first time through the loop, it'll print out the character at index 0. Then we add 1 to index. Next time through the loop, it'll print out the character at index 1, and then 2. And the trick is to stop the loop at exactly the right time before the index gets too big. And it's too big. If the index gets as big as the length, it's too big. So we shut it down. Yeah?
So if we started index at 1 and then did put -1, would it still look the same?
Okay, so she's asking, suppose we started here and we didn't do this. Okay, so what, it won't print out the character, it won't print out the first character in the string now because we started at 1. So it never looked at the one at 0. Furthermore, it's going to try to look at a character that doesn't exist. Yeah?
Could you change that to be like inside the system.print line to be index -1?
Yeah, there are ways we could compensate for it. Let me put it back this way. So what's going to happen if I run the program like this? Actually, I had it, this is the right way to do it to begin with. I think before, I had less than s.length -1, which was wrong. It should have been less than or equal to s.length -1. So actually, this is the correct way to write it.
Yeah.
See? I get these one-off mistakes all the time. What if we let it run too long? What do you think? Yeah? we're going to have so basically, it's going to, at this point here, it's going to ask for an illegal index. It's going to try to do an illegal index into the string, and we'll get an exception. So if I think there's a main method here. So what you get is that we got a string index out of bounds exception. We tried to look at index 8 that didn't exist. And if you come down here and click, okay, these first few lines are in string classes. But if we click right here, it'll take us to the line that had the problem. So when you get an exception, just don't think, oh, things blew up. It'll often tell you exactly where the problem occurred. And it's just telling you index was too big at that point. Then if we fix it, and run it, and it works. So that is a standard enumeration loop for a string. Yeah?
Is that more commonly used than an iterator?
Iterators are a topic for another day. There are lots of ways to write loops. The most fundamental way is with the while loop. So we're going to stick with while loops for now. Now, suppose someone hands you a scanner and says print out all the tokens the scanner contains. So a token is what's returned by next in a scanner. How would you do that? How could we arrange to consume everything in a scanner and print each thing out on a different line? So think about it. Each time through the loop, what should we do if we want to print out a token? How do you get a token out of a scanner? Yeah? Yeah. Scan.next will give you the next token out of a scanner. So if we just set this, while true, that's an infinite loop. It would call scan.next the first time through the loop and print out the first element in the scanner. Then the loop would continue and print out the second element in the scanner, the third, the fourth, and so on. But what would happen eventually? Yeah? Run out of tokens and there'd be an exception. It would, basically it would say there's no token. So if I run it, it says no such element exception, and it happened on line 94. The scanner was completely emptied out and we asked for yet another token and there wasn't one. How can we avoid asking for a token when there aren't any? Yeah? Right. There's a method called hasNext where you can ask, is there a next token? So you just say, while there's a next token, print it out. While there's a next token, print it out. So there's no way we can execute this without there being a token because we checked right here. Eventually, it's going to say no. It's going to say false. There is no next token, and that causes a loop to end. That's a prototypical enumeration loop for a scanner. Okay? So I call these enumeration loops because it doesn't. Each time through the loop, it deals with a separate element of, a separate integer, a separate character, a separate token. It doesn't try to combine them, compare them, anything like that. So I'm going to contrast that with what I call accumulation loops. So I'm going to show you the difference. So here, I want to return the product of the next in integers beginning with start. So rather than print out all the integers, I want to multiply them together. Or rather than printing out all the characters in the string, I want to combine them so they're in reverse order. Or rather than printing out all the tokens in the scanner, I want to add up all their lengths and return that. So these are problems where we've got to combine all of the elements in an interval or of a string or of a scanner in some way. Accumulate them together, if you will. So this is a very common kind of problem. It's called an accumulation loop. So let me show you how this works. I'm going to start with total length because it's probably the easiest. I'm going to go back. This is my standard accumulation loop. So I'm going to copy that. This is my accumulation loop. My enumeration. Everything starts with enumeration loops. That's the most basic type. So go back here. We'll paste it in. Now to turn this into something that will calculate the total length, we need what's called an accumulation variable. So I'll just say total here. When we're all done, we're going to return total. So let's suppose the token contains, the scanner contains a token of length 3, then a token of length 4, then a token of length 6. We want to return 13, because that's what all the lengths add up to. So what do we do in here? We don't want to print out anymore. Each time through the loop, we need to update the total somehow. How do we update the total so that when we're all done, we've added the lengths of all the tokens into the total? Yeah?
Aren't we leaving out white space?
I'm only interested in the total. He said, aren't we leaving out white space? Yes, we are. I'm interested in the links, total lengths of the tokens. I don't care about white space. Okay? What do I need to do in the loop? Yeah?
Total equals total plus 1 every time it goes through.
Well, if I said total equals total plus 1, that's a different kind of accumulation loop. What's that doing? What is it calculating? If every time through the loop I add 1 to total. Yes? Right, I'm counting the number of tokens. Okay? I don't want to count the number of tokens, I want to count the total number of characters in all the tokens. So, total equals total plus what? Each time through the loop, yeah. Well, scanner.next, then I'm sort of appending a number to a string. I don't want to do that. I want to know how many characters are in the string. How many characters are in the token? Let's ask it. And there we have it. Every time through the loop, I calculate the length of the next token and add it to total. When I'm all done, I've added all those lengths together and I return it. So it's accumulating the total length of all the tokens. That's an accumulation loop. And I want you to notice, what did I have to do to change the enumeration loop that I gave you, that model, into an accumulation? What did I have to add? What's here that wasn't in? Yeah?
You have an extra variable that's gathering.
Okay, so I have the accumulation variable, which I returned in the end. And then what else is different? What do you do with the accumulation loop inside? What do you do with the accumulation variable inside the loop? Got an idea? Yeah?
There needs to be a step inside the loop that increases the accumulation variable.
I'm updating it. Every time through the loop, I'm updating. In this case, I'm adding the length to it. But you know, if I was counting, if I wanted to count the total number of tokens, I add 1 to it each time. But I'm trying to add up the total length. Yeah?
So what ends this loop right here?
Okay. What makes this loop end? Yeah?
When has next returns false.
Right. When this returns false. When there are no more tokens in the scanner. When I've pulled them all out. Yeah? Say louder.
You run this thing one more time.
You mean to run it?
You run it. You're going to want to see it in action.
I don't know what, I think that's what got returned, is that 9 right there. If we look at the test case it ran, it asked for the total length of all the tokens in that scanner. Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So just to emphasize what I did, is I pasted in the enumeration loop, and then I added accumulation variables. Now, if you have to write another accumulation loop for scanners, what should you do? What should be your inspiration? What would be the inspiration for the next scanner loop? Next scanner accumulation loop? This one right here. This is a good model. The slides that I didn't go over sort of spell this out, all these different cases. And you can look there too. But this is, if you know you're writing an accumulation loop over scanners, start with an accumulation loop over scanners you've written before. The trick is knowing that you're writing an accumulation loop. And on this next assignment, I'll tell you, write an accumulation loop, write an enumeration loop, whatever. We'll look at different varieties of loops. So what about this one? Return the reverse of S. That's an accumulation loop. You'll have to trust me. Where should we start for inspiration? Well, I'm not going to look at the scanner one we just did for inspiration because that was a loop that consumed a scanner. So the closest thing I have is the enumeration loop for strings. So let's copy that. And paste it in here. Okay. What do I need to change? What are the things I had to add to the, in the case of the scanner? Yeah?
Well, if you make the index start at length -1.
Well, we have the enumeration loop here. What do you have to add to an enumeration loop to get an accumulation loop? What's the first thing you have to add? Yeah? Accumulation variable. Something to hold the result. And we're trying to produce a reverse string, so I'm going to say so reverse string, we're going to build the reverse string here. And when we're all done, we're going to return it. And then each time through the loop, we've got to build a little bit more of the reverse string. So we don't want to print out the next character anymore. What do we want to do with it? Each time through the loop, we're going to get to, that's the next character right here. What are we going to do with it? Let's say the string we're reversing is A, B, C, D. And we've already got a string that says BA. So we've started to reverse it. Where do we put the C? Yeah? You add it to the beginning of the reverse string. Yeah. So we just say reverse string equals character plus okay? Notice I cut and pasted, I put in some accumulation variables. Where is the creativity in writing an accumulation loop once you know the pattern? What are the decisions I actually had to make? Got an idea back there? Well, I had to pick the name of the variable, sure. I had to decide how to initialize the variable. And what's the only other decision I had to make? Everything else is boilerplate, yeah? This bit right here. What to do the accumulation variable each time through the loop. That's the creativity. Everything else is boilerplate, falls out of the sky, because the pattern is the same every time. Now, let's try this out. I put a breakpoint there. Let's try running accumulation loop. So I'm going to run it. Okay, so it got right here. So let's look at our string S. A, B, C, D, E, F, G. So let's start stepping. Index is 0. Index is still less than the length. So S.charadd is going to be A. So when we do that append, reverse string will just be the string A. Increment the index. Start again. What's the string going to be after I execute here? It is BA, because it took the B was this character, and it stuck it at the beginning of reverse string. And so each time through, now reverse string is CBA, DCBA, and so on. So, I'm not saying this is easy. I'm trying to tell you a way to make it easier is to know what kind of loop you're writing and start with a prototype. I'm going to do this last one here. Don't have a lot of time for it. We want to write an accumulation loop over an integer interval. Okay? A good place to start would be another accumulation loop over an integer interval. We don't have one. So we'll go to the enumeration loop and copy it. And paste it here. So how do you turn an enumeration loop into an accumulation loop? What do you add at the beginning? You have to add an accumulation variable. Okay? What do you add at the end? you return the value of the accumulation variable. No thought required. And then, in here, you do something with num and prod. Somehow you got to combine them. So this is a creative part, and this is a creative part. So if someone said multiply the numbers together, what would, let's say start is 3 and n is 5. So we're going to multiply in 3, 4, 5, 6. Where should we start product? Should we make it 0? If we make it 0, then we're going to be multiplying things into product. It's going to stay 0. A good first guess is to always use the identity element. When we're adding up total lengths, 0, because we're adding. When we're doing a string, empty string. We're doing products, what is sort of the logical first thing? Yeah?
1.
1. And then each time through the loop, how do we update prod? The new value of prod is equal to the old value of prod. What do I do? Yeah? Multiply by num. So we took the accumulation loop and we added. We initialized the accumulation variable, we return the accumulation variable, and we multiply, we update the accumulation variable. That is how you always turn an enumeration loop into an accumulation loop. Okay? We'll come back to this. There are more examples to look at next time. But do get started on the assignment even if you get stuck, because